first apply the Laplace transform all the way. Okay, so apply Laplace to all of them. The Laplace of y triple prime, Laplace of y double prime, 3 coefficient, Laplace of y prime, minus 5, Laplace of the y equals 16, Laplace of e to the negative t. Okay, for the triple prime, n is 3, so s to the third, uppercase y, minus s squared, y at 0, minus s to the first, y prime at 0, minus s to the 0, y double prime at 0. You see it kind of back down one by one for the power the s, and then starting from the lower order of the initial condition until the last one. So plus 3, no, not 3 yet. So this is the second order. The second order gonna be s squared, capital Y minus s to the first power, the lowest order of the initial condition, minus s to the 0, the next order of the initial condition. And that's it. You need 2 conditions for the second order. And the last one is s to the first, capital Y, minus s to the 0, and the lowest order of the initial condition, minus 5, capital Y equals 16. And this is e to the power at, where a is negative 1. Okay, if a is negative 1, what we do is, let me see, e to the negative 1. So then this gonna be 1 over s minus 1, s minus negative 1, or s plus 1. Okay, from the Laplace of e to the at is 1 over s minus a. Okay, so far so good.
Yep.
Okay, good. Y at 0, this is 0. Y at 0 is 0. That's nice. That's nice. And then y prime at 0 is 2. So this is 2. And this is 2. Y double prime at 0 is negative 4. This is negative 4. Yep. And then just clean up. We have s to the third times capital Y minus 2s. This is negative, negative, positive 4 plus s squared, capital Y, minus 2 plus 3s, capital Y, minus 5, capital Y, equals 16 over x plus 1. Okay? And collect the y term all together. We have s to the third plus s to the second plus 3s minus 5 of the uppercase y. And then move the non-y term to the right together with 16 over s plus 1. So we have to be careful with algebra here. So we have negative 2s, the 4 minus 2, that becomes plus 2. Okay, so on the right hand side, it becomes plus 2s minus 2. Capital Y, we solve for capital Y, it's going to be 16 over s plus 1 plus 2s minus 2, all divided by s to the third plus s to the second plus 3s minus 5. Okay, what you got? Negative?
Negative 2 over x plus 1 plus 1 over s minus 1
Mm-hmm.
plus s plus 1 over s squared plus 2s plus 5.
Okay, all right. Yep, the same as what I got. Thank you.
Yep.
So, so the uppercase y is the Laplace of the lower y. what we're gonna do the inverse Laplace of each term. The first term is okay because we see the coefficient and the s minus the number, right? The second term s minus the number. But the last one, we have to work on it a little bit. So s, since it's not factored, so we have to do the completing square. Another layer of algebra that you have to do. So s squared plus 2s, so make the perfect square. So we add 1 minus 1 plus 5. You see what I do? For the first two terms, to make a complete square, you add another term to make the first three terms to be the perfect square. Since the second term here is the double of the product, the first term, the last term, to find the perfect square, so 2 divided by 2, which is 1, and then we do this as 1 square. Do you recall this process? The perfect
Yes.
square. So now this becomes s plus 1 quantity squared, and then left over here, which is 4, right? May plus 2 squared. So we get negative 2 over s plus 1. So I'm going to rewrite it as, uh, it's already 52. We have to go soon. All right. So s minus negative 1 plus 1 over s minus 1. This one is already s plus 1. We have s plus 1 on the top, so we don't have to do much. And the Laplace transform of e to the power a t times the cosine kt is the s minus a divided by s minus a square plus k square. That's a formula from 7.1. And now we have s minus negative 1. This is s minus negative 1. So this case, the a is negative 1 and the k is 2. Okay, so the last term here, it's gonna give us as a e to the power times the cosine. So the last term, we don't have to change anything. After we just do the perfect square on the denominator. So you have s minus negative 1 divided by s minus negative 1 quantity square plus 2 square. And this is the y. And we're going to do the inverse Laplace of the whole thing and come out to be the small y or the solution. So this is negative 2 times e to the negative 1 times t. Second is e to the power t. And the last is e to the negative t multiplied by the cosine of 2t as a solution.